Alright, welcome to page 4, 7.1 and 7.2, and here we're going to do the Laplace transformation of f of t, where f of t happens to be a piecewise defined function. So we're going to put it in our integral from 0 to infinity, where we have e to the negative st times f of t dt, where f of t is our piecewise defined function. Because it's piecewise and negative, and our function is -1 from, t is less than or equal to 4, and we're going from 0 to 4, our integral from 0 to 4 is going to be e to the negative st of -1. But when we're dealing with an interval greater than 4, so plus 4 to the infinity, we have e to the negative st, and our function is 1 whenever we're dealing with an interval that's greater than 4. And so now we're just going to do the integration for both of these separately. And so we have negative e to negative st. Well, if I take the integral of that, it's just going to be 1 over s e to negative st. If I take the integral of e to negative st, it's going to be -1 over s e to negative st. Now we're going to plug in our values. So we're plugging in 4 for t, so 1 over s times e to negative 4s minus plug in 0, that's going to be 0, so it's just 1 over s. Plus, plug in infinity, this part when it's infinity is going to converge to 0, and then plugging in 4, we get 1 over s, we get plus 1 over s e to negative 4s. And since I have two of those, I'm going to add those two together and get 2s e to negative 4s, then have this minus 1 over s right there, and we're finished. Alright, example 7. We're going to, we want to do the Laplace transform of sine of 2t. Now, if you have to do the Laplace transform, of sine of 2t or cosine squared t, not sine of 2, sine squared t, cosine squared t, what you want to use is that half angle formula that we have. So sine squared t is really 1/2 minus 1/2 cosine 2t. So we're going to do the Laplace transform of this. So if we can write a function a different way first, if it's easier to deal with, that's what we're going to do. And that's what we did here. I'm going to pull the 1/2 out and do the Laplace transform of just 1 for this first part. And pull out the minus 1/2 and do the Laplace transform of cosine 2t. And so the Laplace transform of 1 is just 1 over s. So 1/2 times 1 over s is going to give me 1 over 2s. And then the Laplace transform of cosine 2t, our k is 2. And so remember, for cosine, it's s divided by s squared plus k squared. So it's s over s squared plus 4. And we have this 2 there, so I'm just going to, multiplying it by, negative 1/2. And so here's my answer. 1 over 2s minus s over 2 times the quantity s squared plus 4. And that's it.